Good morning, everyone. Today we're going to discuss Module 1 of Science 7, Quarter 3, Part 1. And this is entitled Let's Do the Motion. This is our topper, your Science 7 teacher. Before we proceed, let's have the morning prayer. Lord, thank you for a new day. Please go before me and clear the way. Thank you for protecting me. Thank you for guiding me. Thank you for loving me. In Jesus' name, amen. So let's proceed. So this module is entitled Let's Do the Motion. Module 1 of the third quarter. What I need to know. You observe a lot of moving objects every day. Some objects move along a straight line, like a car traversing the highway, while other objects move in circles, like a rotating disc. Because you experience motion on a daily basis, you may find it ordinary and unnecessary to learn. In physics, however, learning about motion requires understanding of the quantities related to it. These quantities include a distance or displacement, speed or velocity, and acceleration. What I need to know. This module provides you with the essential concepts and activities necessary to describe motion along a straight path and in terms of position, distance, and speed. We will learn to interpret and analyze motion of objects through charts, diagrams, and graphs. After going through this module, you are expected to first describe the point of reference of an object and differentiate the distance and displacement covered by an object. What I know. So again, this is our review. Let us see what you have in your stock knowledge. Directions. Choose the best answer from the given choices. Key in your answer in our class point up with the class code of 33372. I repeat, class code 33372. Let's start. Question 1. Which refers to the length of the entire path traveled by an object? Is it A, displacement, B, distance, C, motion, D, time? Okay, time is up. And the correct answer is letter B, distance. Let's have question number 2, which refers to the shortest distance between two objects, two positions. Is it A, displacement, B, distance, C, motion, D, time? Very good. Correct answer is letter A, displacement. Number 3 question. Let's move on. The change in position over an interval of time is called blank. Is it A, displacement, B, distance, C, motion, D, time? Very good. That is letter C, motion. Number 4. The distance traveled by an object, how fast the object is traveling, and the direction in which the object travels to is measured with respect to blank. A, motion, B, distance, C, displacement, D, reference point. Okay, the correct answer here is letter D, reference point. Let's have question 5. If an object is in motion, it changes position relative to its blank. Is it A, time, B, angle, C, speed, D, reference point? That was correct. It's letter D, the reference point. Let's have number 6 question. Displacement can be equal to distance when blank. Is it A, object is in circular motion, B, path traveled is a straight line, and C, ball is rolling on an inclined plane, or D, car is traveling on the road upward? Okay, time is up. The The correct answer here is letter B. Path traveled is a straight line. Number 7 question. Which of the following describes the distance covered by an object? Is it A, 5 seconds, B, 8 meters, C, 10 meter per second, or D, 12 meters north? Very good. The correct answer is letter B, 8 meters. Let us have number 8 question. Which of the following shows the displacement traveled by an object? Is it A, 9 seconds, B, 18 kilometers, C, 27 kilometers per hour, or D, 36 kilometer due south? Very good. The correct answer here is letter D, 36 kilometers south. Number 9 question. All of the following are the materials used in measuring the distance covered by an object, except blank. A, ruler, B, timer, C, meter stick, D, or measuring tape. Very good. The correct answer here is timer, letter B. Let's move on with question number 10. Ethan claims that the house where he lives is actually constantly moving. Which of the following points of references do you think will best support his claim? Is it A, earth, B, floor, C, house, or D, sun? Very good. It's letter D, sun. Let's have question number 11. When is an object considered to be in motion? 1. When its position changes with respect to a point of reference. 2. When its distance changes with respect to a point of reference. 3. When its direction changes with respect to a point of reference. Is it A, 1, 2, and 3, B, 1 and 2 only, C, 1 and 3 only, and D, 2 and 3 only? Very good. That is letter A, 1, 2, and 3 are all of the above. Number 12 question. Geoffrey walked 300 meters east from home to visit Matthews. He then walked another 500 meters east to fetch Jen, and both of them walked 300 meters west to watch the birds. Which of the following statements is true? A. Geoffrey went home. B. Geoffrey has traveled a total distance of 1,000 meters. C. Geoffrey's displacement is shorter than the total distance he has traveled. Or D. Geoffrey's displacement is 0 if he has traveled 700 meters west together with Jen. Very good. The correct answer is letter C. Geoffrey's displacement is shorter than the total distance he has traveled. Let's proceed with question number 13. Which of the following is true about an object that travels 5 meters to the left, then another meters or 5 meters to the right? Is it A, the displacement of the object is equal to 10 meters? B, the displacement of the object is equal to 10 meters right? C, the total distance traveled by the object is equal to 10 meters? Or D, the total distance traveled by the object is equal to 10 meters right? Very good. That is letter C. The total distance traveled by object is equal to 10 meters. Let's proceed with question number 14. Jenilyn was asked by her science teacher if an object's displacement can be longer than distance. She answered no. Is Jenilyn's answer correct? A. Yes, displacement can be longer to the distance. B. No displacement is the total length covered by an object in motion. C. Yes, displacement is the longest length between two objects point of origin and its point of destination. Or D. No. Displacement is the shortest length between two objects' point of origin and its point of destination. Very good. It's letter D. No. Displacement is the shortest length between two objects' point of origin and its point of destination. Let's have the last question. Okay, question number 15. Leia, an inspiring athlete, runs the oval. The oval has a total length of 1,500 meters. She always finished running 2 laps as part of her daily routine. Is it true that her total displacement is 3,000 meters east? A. No, because her total displacement is equal to 0. B. Yes, because she finished 2 laps, which is equal to 3,000 meters. C. No, because her total displacement should be 3,000 meters west. Or D. Yes, because her displacement is equal to her total distance covered. Okay, the correct answer for this question is letter A. No, because her total displacement is equal to 0. Okay, so for today, we're going to discuss all about Module 1, Lesson 1 of the 3rd quarter in Science 7, entitled Distance and Displacement. So in this module, we're going to differentiate distance from displacement. What's in? How an object moves is described relative to something else. Before you will be able to describe the motion of an object, you must first be able to tell exactly where it is positioned. Describing exact position entails 2 ideas. First, describing how far the object is from the point of reference, and describing its direction relative to that point of reference. In other words, the distance traveled by an object, how fast the object is traveling, and the direction in which the object travels to are measured with respect to a point of reference. In a general sense, you can say that motion is accompanied by a series of movements. That is, for an object to be in motion, it must move from its initial position to a final position. And the question is, how do you scientifically describe the motion of an object? So let's have this. What's new? Let's have the activity 1, Introduction to Motion. So you're given a scenario here, directions, study the picture, and answer the succeeding questions. You may write your answer in a separate sheet of paper. So, the scenario is a ball rolls rightward towards the tree while the car moves leftward towards the same tree. So, figure 1, the ball and the car moving toward the tree. Okay, as you can see, starting point of the ball is negative 30 meters. The left of that reference point, the tree, so negative 20 meters, negative 10 meters. And from the right side of the tree, we have the distance of this car from the tree is 30 meters. And this is 20 meters. Okay. That's how to answer the given question. Guide questions. Directions. Write your answers on a separate sheet of paper. Okay. Question 1. How far originally is the car from the tree? That is correct. It's 30 meters. Number 2. Before they started moving, what is the original distance between the car and the ball? So it is 60 meters. So 30 from the left and 30 from the right. So you add them, you have 60 meters. Number 3, if the car moves a distance of 2 meters in 1 second, how far will it be from the tree after 5 seconds? Okay, so just multiply it, 5 and 2. So we have 10 meters. Number 4, Suppose the ball covers a distance of 1 meter in 1 second. How much distance can it cover in 5 seconds? The same. 5 times 1 simply have 5 meters. Okay? We're talking about distance, so the unit must be in terms of distance. Okay, let's move on. Motion upon object. In the illustration above, you could say that both the ball and car moved with respect to something else. That is considered to be not moving, the tree. Again, this is the reference point, the tree. You know that the ball moved because its position has changed from its initial position to the location of the tree after some time has passed. The same can be said of the car. The location of an object at any particular time is its position. An object is moving if it changes position relative to a reference point after a passage of time. So let's deal with figure number entitled A Car in Motion. As you can see, you are given above the time and below the distance. So 0 second, we have 0 meter, and it is 1 second, we have 10 meters. If it is 2 seconds, we have 20 meters. If it's 3 seconds, we have 30 meters. So we can say that we can multiply it by 10. So the interval is 10. So 2 times 10 is 20. Then 3 times 10 is 30. So that's the easiest way. Okay, suppose you take the 0 meter mark at time t is 0 as the point of reference in figure 2. After 2 seconds, the car traveled a distance of 20 meters. However, if you take the 20 meter mark as a point of reference, you will find that the car will cover a distance of 10 meters after a second. Generally, you are free to choose whichever point of reference you favor, but most would choose the origin, or the starting point of the position at time equals 0 second, for convenience. Objects that are fixed relative to Earth, such as a tree, building, or post, make good points of reference. To fully describe motion, you need to describe first the object's position. Before the car moves towards the tree, the car was in its starting position. Upon reaching the tree, the car has changed its position. Its new position was in the front of the tree. How far has the car moved? The car has moved 30 meters. The distance an object moves is the total length of path traveled from its initial position to its final position. It refers to how much ground the object has covered during its motion. The description of an object's motion often includes more than just the distance it covers. If the distance between the car and the tree is 30 meters, then the distance traveled by the car is 30 meters. But imagine that the car moved back to its initial position from the tree. At this time, the car has traveled a total distance of 60 meters, but the car ended up in its same starting point. Even though the car has moved a total distance of 60 meters, its displacement is 0 meter. Again, displacement is the object's overall or net change in position. It refers to how far out of place an object is from its initial position. If you only describe the car's initial movement, then the distance traveled and the displacements are the same, which is 30 meters. But if you describe the back and forth movements of the car, the distance and displacement are different. In describing distance, only the magnitude or size or the amount of the distance traveled is considered. However, in describing displacement, both the magnitude of the change in positions and the direction of the movement are considered, such as distance is a scalar quantity, while displacement is a vector quantity. When we say scalar, we talk about only the magnitude or size. When we say vector, it involves the magnitude and the direction of the movement of the given object. Take a look at the other illustration below. So figure 3, a ball at the 0-meter position. Starting niya, so move to the right with 2 meters and ends with 3 meters, and this is the 4 meters. And then going back, so we have 1 meter. So in here, from 1 meter to 3 meter. So this one is simply 2 meters, this is 1 meter, and this is 2 meters. So explanation. A ball is rolled 2 meters to the right, this is it. Then rolled 1 meter to the left, this is it. It is again rolled 2 meters to the right, again. During the course of this motion, the ball has covered a total distance of 5 meters. Okay, so all you need to do is add them. So 2 meters plus 1 meter plus 2 meters, which is 5 meters. However, the ball's displacement is 3 meters to the right, or 3 meters east. This is 2 meters east plus 1 meter. Okay, and west is 2 meters. Then east equals 3 meters east. Okay, in this case, add the magnitude of the same directions. We have 2 meters east plus 2 meters east equals 4 meters east. So these are all bound to the east. Then subtract the magnitude of the opposite directions and follow the direction of the bigger magnitude. So we have 4 meter. So east minus 1 meter. So it will be west equals 3 meters. Okay. Note that the direction is present when describing the displacement of an object or body. Okay, let's move on. Points to remember. In solving for the distance, get the sum of all the magnitude of the object in motion. And in solving for the displacement, get the sum of the magnitude of the same directions, then subtract the magnitude of opposite directions and follow the direction of the bigger magnitude. Okay? Activity 2. What's more? How far? Direction. Study the illustrations below showing the displacement and distance covered by the dog. Figure 5. A dog showing its total distance and displacement covered. So as you can see, the figure there, it's A, B, C, and D. We have north, south, east, west. Okay, directions. Okay, let's have the guide questions. Write your answer in a separate sheet of paper. 5. What's the starting point of the dog? That is point A. Define point of reference in your own words. It is the particular point in a space. 7. What is the distance covered by the dog from point A to point D? It's 25 meters. And 8. What is the displacement of the dog? 5 meters. Okay. Number 9. Suppose the dog goes back to point A as its final position. What will be its displacement? It is 0. 10. Is it possible to get 0 displacement? When can displacement be equal to 0? When the object ends with the original position. 11. Suppose the dog travels only from point A to point B. What will be its total distance covered? How about its displacement? Distance and displacement are the same, and it is 10 meters. Number 12. When can displacement be equal to distance? When an object moves in a straight line in the fixed direction without coming back. 13. Can displacement be greater than distance? Why or why not? Yes. Magnitude of displacement can be equal to distance traveled by object in a straight line. In effect, or example, rectilinear motion. Number 14. Give one difference between distance and displacement based on the given example. Okay, answer. Distance is the sum of the distances traveled by the dog, while displacement is a distance only from starting to finish points taken by the dog. Okay? So, what I have learned, they are given here directions. Read the paragraph carefully and identify the word from the box that will complete each sentence correctly. Write your answers in your activity notebook. So, this is the box consists of distance, reference point, direction, moving, odd, difference, motion, displacement, destination. So, I'm going to give you this with our class point short answer. Okay, so check. Okay, so let's reveal the answer. Okay, so first blank is motion. It is defined as the change in position over an interval of time with respect to a reference object. An object is said to be moving when it has traveled a certain distance from the reference point or it is displaced from the reference point. In other words, the distance traveled by an object, how fast the object is traveling, and the direction in which the object travels to are measured with respect to a reference point. A distance is a scalar quantity. It has magnitude but no direction. To get the total distance traveled by a body, all we have to do is add all the distances traveled. On the other hand, displacement is a vector quantity, for it has both magnitude and direction. It is the difference between two positions. Moreover, distance does not always follow a straight line, unlike with displacement that always follows a straight line. Displacement measures the length of the straight line that connects the object's point of origin and its point of destination, while distance measures the length of the path traveled by the object. So we're done with what I've learned part. So you're given here directions. Elaborate the Filipino quote below and relate it to the concept on the importance of specifying the reference point when describing the distance and displacement covered by an object. Write your answer on a separate sheet of paper. So I will give you this as your assignment. Ang hindi marunong lumingon sa pinanggalingan ay hindi makakarating sa paroroonan. So here is the rubric with the content and organization. Please concentrate on the highest point, which is 5 points, for you to have a good score. Okay, so let's have, before we end our class, let's have the assessment. Okay, so directions. Choose the best answer from the given choices. Key in your answer in our class point up with the class code of 333372. Are you ready? Okay, number 1. Which refers to the length of the entire path traveled by an object? Is it A, displacement, B, distance, C, motion, D, time? Very good. It is letter B, distance. Which of the following describes displacement? A, it has direction only. B, it has magnitude only. C, it lacks magnitude and direction. It has both the magnitude and direction. Very good. You know the lesson very well. It's letter D. It has both the direction and the magnitude. Number 3. Which of the following measures the length of the straight line that connects the object's point of origin and its point of destination? Is it A, motion, B, distance, C, displacement, or D, point of reference? Very good. That is letter C, displacement. Number 4. Which of the following shows a distance covered by an object? A, 15 seconds, B, 20 meters, C, 10 meters per second, D, 5 meters due east. Very good. That is letter B, 20 meters. Number 5. Which of the following best differentiates distance from displacement? A, distance is a vector quantity while displacement is a scalar quantity. B, distance follows a straight line while displacement does not always follow a straight line. C, distance is the total length of the entire path traveled by an object while displacement is the shortest distance between the object's two positions. Or D, displacement is the total length of the entire path traveled by an object while distance is the shortest distance between the object's two positions. Time is up. It's letter C. A distance is the total length of the entire path traveled by an object, while displacement is the shortest distance between the object's two positions. Let's move on. Question 6. Concentrate with the figure. For numbers 6 to 12, analyze the illustration given below and answer the question. So, this is about the reference point of the car, the ball, and the house. What is the position of the car with the house at its reference point? A. Negative 10 meters. B. 0 meters. C. 40 meters. D. 50 meters. That's correct. It's letter D. 50 meters. Number 7. What is the position of the ball with the house as its reference point? Is it A. 0 meter. B. 10 meters. C. 20 meters. D. 40 meters. Very good. It's letter C, 20 meters. Number 8. How far is the car from the ball? A. The car is 30 meters to the left of the ball. B. The car is 20 meters to the left of the ball. Or C. The car is 30 meters to the right of the ball. Or D. The car is negative 10 meters to the left of the ball. Correct. It's letter A. The car is 30 meters to the left of the ball. Number 9. If the ball moves from its position to the 30-meter mark, what is its displacement? A. 0 meter. B. 10 meters. C. 20 meters. Or D. 30 meters. Very good. That is letter B. 10 meters. Number 10. Suppose the car moved 20 meters to the right, then turned 10 meters back to the left. What are its distance traveled and its displacement? A. The distance will be 30 meters and the displacement will be 0. B. The distance will be 20 meters and the displacement will be 10 to the right. Or C. The distance will be 30 meters and the displacement will be 10 meters to the right. Or D. The distance will be 10 meters and the displacement will be 10 meters right. Okay, that's correct. It's letter C. The distance will be 30 meters and the displacement will be 10 meters due right. Very good. Let's proceed with question 11. Assume that the ball moved to the house and rolled back to its original position. How far would the ball travel and what would be its displacement? Is it A. The distance and the displacement of the ball from its reference point would be both 40 meters. B. The distance and the displacement of the ball from its reference point would be both 0 meter. Or C. The distance of the ball from its reference point will be 40 meters and its displacement would be 0 meter. Then D. The distance of the ball from its reference point will be 0 meter and its displacement would be 20 meters. That is correct. It's letter C. The distance of the ball from its reference point will be 40 meters and its displacement would be 0 meters. Let's have question number 12. Assume that the car moved to the house and moved back to its original position. What would be its distance and its displacement? A. The distance traveled, displacement of the car would be both 100 meters. B. The distance traveled by the car will be negative 10 meter and its displacement would be 40 meters. C. The distance traveled by the car will be 0 and its displacement would be 100 meters. Or D. The distance traveled by the car will be 100 meters and its displacement would be 0. Very good. The correct answer is letter D. The distance traveled by the car will be 100 meters and its displacement would be 0. Let's proceed with question number 13. If the position of an object is not changing, what do you think does this indicate about its displacement? A. Displacement is 0. B. The displacement is lesser than the distance. Or C. The displacement is greater than the distance. Or D. Displacement is the same with the distance traveled by an object. Very good. It's letter A. The displacement is 0. 14. Glenn was asked by his science teacher if an object's displacement could be shorter than distance. He answered yes. Is Glenn's answer correct? A. Yes. Displacement is always equal to 0. B. No. Displacement is the total length covered by an object in motion. C. No. Displacement is the longest length between two objects' point of origin and its point of destination. Or D. Yes. Displacement is the shortest length between two objects' point of origin and its point of destination. Very good. The correct answer is letter D. Yes. Displacement is the shortest length between two objects' point of origin and its point of destination. Then we have the last. Is it correct to say that our house is constantly moving when its reference point is the sun? A. No. The house will only move when an earthquake occurs. B. No. The house as a reference point is not affected by the sun. C. Yes. Since the house is placed on the earth's ground where the sun is constantly moving. D. Yes. Since the house is placed on the ground where the earth is constantly moving around the sun. Very good. You got it right. It's letter D. Yes. Since the house is placed on the ground where the earth is constantly moving around the sun. Okay, so you're given an additional activities. So this will be your second assignment. Activity 3, measuring distance and displacement. You are going to follow this. Then, go back with the lesson and answer guide questions. Okay, if you don't have any question with the lesson, so this is our topper saying thank you and good morning.